SABIC R&D, so the Basic Industries Corporation. As a scientist, and my area of expertise ranges from model-based plant support, fundamental modeling, energy studies, technology, benchmarking, selection, PDP, licensing, lots of this. I will talk in later. I did my masters from 2012 to 14 in chemical, and I was first in the Vikings, the hostel Vikings, hostel 6, I think, if I'm correct. And then I went to Silicon Ship, which is hostel 14, and my MTP was in modeling of anisotropic nanoparticles. My guides were Professor Anurag Mehra and Lochis Thaukar. They had big influence in the way I do things. And as you can see from the bottom to top, if you go look here, I was in the world of nanoparticles. From there, I went back to the world of kilometer meters and all this thing. And this was quite a journey for me. And how and in this process, I evolved also myself. My hobbies involved, I'm a passionate food blogger. I love traveling. I love cooking, and I'm a sports enthusiast. So these are my couple of memories what I posted here for our batch as the IITP memories I had with me when I left the campus. So going with the theme of this evening, I will just start explaining why we need the that higher study and what about it. What are the different aspects available? Next slide. Next one. So see, when we talk about higher studies, in this world, everything evolves. Even from nature to everything evolves, and people likes to differentiate. Everyone, likes to get differentiated from each other. So, like, a simple example: if you go to buy a mobile phone, we look at the 6,000 mAh battery is there, this much of camera is there, so one company is giving you some spec, other company is giving you another spec. So this is mobile. If you want to go for car, watch, anything, you try to buy the best, because there are lots of features, lots of additional things being given to all these products. Similarly, like for higher studies, why we should do higher studies part, it's a basically not a it looks like a simple question, but it is not. So here I would like to mention that we all have a chance to differentiate ourselves from the rest of the people who are not doing, by doing a higher study. Now, how it helps? So does that mean that who are doing jobs are uh, you know not able to differentiate themselves? Yes, absolutely they are. They are able to differentiate themselves by the kind of job they are doing after B.Tech. But suppose if I go for a M.Tech or MS, so this gives me an advanced knowledge on the subjects I'm learning right now, like say heat transfer, mass transfer, fluid mechanics, process control, all these things. You have advanced knowledge, advanced study. Now the question will be that how this advanced knowledge is applied, or where I'm going to apply. There are different scenarios, different ways you can apply this kind of knowledge. But it adds to your kitty a niche skill which you don't have after B.Tech. In normal scenario, you don't have. Yeah, people do projects, people do lots of internship, that adds. But going through this kind of higher study adds, first of all, niche skill. Secondly, it enhances your problem solving capabilities. So if we take an example of say PhD, it's like an on-job training. So after masters, when I joined the job, I was given a project and I needed to resolve this project. It's a live problem. Similarly, in a PhD, when you go through a PhD, you are given a problem, you need to solve it. There are multiple ways to solve, but the your way you can solve it, and that will be the way to solve in your opinion, and that's how you get a PhD. That you solve this problem, you, as a result, you have this kind of papers or patent as an outcome of that. But the learning part is that how you tackle a problem, how to solve a problem, that actually optimizes your approach to how to solve this problem. So this similarly for MTech, if you look at MS, you read a couple of advanced topics, and based on that you work on a project where you get a feel that how actually you can solve an issue. how you can solve a problem what is happening. So for my example, in nanoparticle modeling, when I did, so the problem statement was very simple, that you have to develop a tool which can predict the nanoparticles we are forming in the lab. But when you break it down, it has several dimensions, like learning how it goes on, what are the different numerical methods applicable into it, and then how good is your algorithm, what other people are doing in the world, how you get to understand that, differentiate your thing from them, and then make a better one which is existing. So in this process, during this MTech, MS or PhD, you also get to know that what is happening in this world in the particular area of research, and then also you try to your comprehension skills, that how it is, what is happening around the world, that also changes, that also improves slowly, because you go to a particular topic, you go to the journals or the patents what are available from the available sources, and that builds up your understanding, firms up, reinforces your understanding on a topic. Now how that helps in a real world scenario, like if you go to a job in R&D or couple of areas after say masters or PhD, how it helps. So this is basically a kind of training we are getting during the higher studies. But in a real corporate R&D kind of setup, you will be given this kind of problem, and there will be many more people will be working with you, and you will have a responsibility. And based on your deliverables, the other people's deliverable will be depending. They will get affected if your deliverable is late, or you are not performing. So it's basically part of the whole value chain. So here, this kind of training helps you deliver, makes you prepared for the next role what you go in any of the industry or any of the role in the future. So why don't we take this opportunity to differentiate ourselves, to have niche skills in a particular area, and also if we have a passion for a particular area, suppose say for bio or nano based, or pharma, or any modeling, simulation, anything, why don't you pursue that and go take it to the next level? And that's how the notion of the higher studies comes in. So to give you one example is that if you don't do, you can ask me that, do I, if I don't do, can I not, I mean I'll be able to do or not, or this is a different aspect. But if higher study in MS PhD, that's the one of the things which people looks for while doing higher study. Similarly, as I mentioned, MBA here, MBA is obviously a different dimension we are going in. So there are like finance, there are HR, there are marketing, different aspects are there. So it's a non-technical aspects where you need sometimes your data science skills, your analytical skills also, they will be very much sharpened by this kind of uh, MBA programs. And also you can have MBAs in oil and gas. If you want to be in the coal line, you can have MBAs in oil and gas. So that also adds to your understanding. You have a deep technical knowledge in chemical engineering. You have management kind of understanding from the MBA in oil and gas. That adds to your kitty. So overall, uh, these are basically enhancing your skills. You can pursue your passion in the long run. You will have job satisfaction, and this is how you should. This is the reason you should technically pursue higher studies. One of the main reasons is differentiation from each other. Now with that, I can go to the next slide where I'll explain that if I'm doing a job after B.Tech, what are the pros and what are the cons? Now it's not a black and white thing the way I have tried to explain. For the sake of simplicity, it's a gray area. Why it's a gray area? First of all, if you are passionate about working, hands-on experience, yes, jobs are the chemical engineering plant experience is very good. And I forgot to mention one more thing is chemical engineering is a very versatile topic. It has application everywhere. It's a very versatile topic. So when you're doing a job after doing a B.Tech, You will have hands-on experience, you will have in-depth knowledge on not only on one subject, on a multiple subjects. Like we have read mass transfer, heat transfer, process control, instrumentation, fluid mechanics, many of the subjects we have read, even cost plant economics and all these things we have read, transport phenomena and uh, mechanical operations, all these things. But in the plant, you will see real time how all these subjects work in tandem, work together to create value, basically to create the run the plant. Now, these kind of understandings, you'll reinforce your, basically you can validate. When I talk to my friends who are in plant, they say that it validates what they read in their books. But it is much more than that. So you have validation of your ideas, what you read, and then it adds the practical nuances. So running a plant, if it is same licensor, same technology, same field, but there are certain nuances in running a plant which you can only gain by hands-on operation. So if you are passionate about that hands-on operation on running a plant, this is a good area. But how it will help you in the future? Future, once you see those technologies working in front of you, the next point will be going through the understanding how it helps and how they model this technology, how they develop this technology. That question will automatically come, and that way, later in the course of your career working, you may be attracted to a higher study to have those additional skills, say for reactor operations. Reactor operations have a reactor, chemical reaction going on, but it needs lots of process controls into it, lots of heat transfer, lots of master, all these things are there. So having controlling a multi-phase reaction, a dynamic reaction which goes on real time, how the technology is developed, how everything goes on in a clockwork precision. The next question comes into an inquisitive mind: how to do that? And to have those kind of skills, we need to go for higher study. But if you don't go for higher study, will it not be helpful? Yes. Then you can go for the EPCs where you design those technology. The technology is there. The plant has to be built in. You can go in with your plant knowledge into those design companies where engineering, procurement, and construction, and from end to end you can go into the different topics like say PFD development, PNID development, equipment design, how the equipment will be sitting in a particular plot, where it will be sitting, what are the line hydraulics, those things you can learn from there. There can be bigger opportunities also, like in the Middle East or in other places. There are lots of petrochemical plants is supposed to come up after the pandemic has slowed it down, obviously, but supposed to come up. So this can have bigger opportunities. But having said that, there are some points what I would like to highlight. One is the work-life balance. So generally in the initial phase of your career, the plant experience is kind of not a 9 to 5 thing. It's like a shift wise. That is one of the areas you may or may not like. Just I am giving you pointers for your consideration. Second is that the future career prospect means in the plant experience you have a one dimension, so you know many things, but in the plant environment or operational excellence area you may need to stay. If you are only going with plant and you are not adding any niche skills which can attract other employer to take you in a bigger role or in a improved role in a some process, that is one of the thing. And third is that you can have much more potential. If you go for higher studies with you can have much more unutilized potential which is not coming out. Basically if we're going that, yeah, it's good to have this plant experience, but in addition to that, with this reinforced understanding, you can do much more in the research area. You can, in this research area of these things which are running in the plant, you can do much more. So that opportunity is lost. And once you start working there, you enjoy that, it's a different thing. But if you don't enjoy, that becomes life harder. So think about it, and the choices you have. These are the pros and cons, grossly or holistically, you can face. So to give you an example, like I have a friend who worked in Reliance after B.Tech. So in plant operations, then he moved to UOP. UOP, he was in design and all this type of thing, designing the technical, designing the plant. And then after that, he understood that his call is somewhere else, so he joined the consultancy. So now he, with his enhanced understanding of how a plant works, how a plant runs, now he is designed the plants and now he's doing consultancy. So the end-to-end part he has seen, and there he is doing good. He is doing consultancy, but at the same time he is not looking for courses or he is looking for any higher study, any degrees, which can help him go to the next level, which can reinforce his understanding in the consultancy, in solving problem solving and all these things. Coming to the second example, one of my friends, she was in plant operations. Then she moved to EPCs, like the plant design and development and commissioning till commissioning. So there, and then she understood her call is somewhere else. So she did M.Tech from IIT Kharagpur, and now what she is doing is she has joined a market intelligence firm. So what market intelligence is doing, what she is doing, she's working in IHS or Nexant, I think one of the companies, Nexant most probably. And Nexant, what they do, they are a technology aggregator. So they take information from the whole world about the technology which is coming in from different companies. They evaluate that and give a comparative comparison that which one the technology, what are the pros and cons, and how, which one is better. And that requires lots of input like raw material to product pricing to the plant line sizing cost and everything. Now those of her expertise is coming into there. So that's how she transitioned into one of the other roles also, like from operations to directly market intelligence. So if you go to the next slide, uh, let me, yeah. So now after the B.Tech, assuming that you want to go for higher study, there are multiple areas of interdisciplinary research which exist. One of them is sustainability. So as you see here nowadays, due to the climate targets for the Geneva Convention thing, climate studies and climate targets, there is lots of things are going on in sustainability, like net zero. There is science-based targets. You can Google. You have sites. You can have lots of material there. So what they are doing in the whole value chain, from the product to the upstream and downstream of any plant. So we are taking raw material to produce some material in the plant, and then we are selling to a particular customer after processing, and we are consuming steams, we are consuming electricity, and that actually adding to the pollution, that actually adding to the carbon emissions from these plants. There is a huge area of research going on in making things sustainable. To give you an example, the Magnum ice cream what you eat, the tub what you buy from the Magnum, it's basically made of the recycled plastic. And they all these companies have to meet their targets for the sustainability by 2030. Otherwise, people will not invest in them. That is one of the gold standards they are setting. How sustainable? There's the reduction of paper and all these things we see on ground when we order from say Zomato or Swiggy. They don't give the cutlery. All these things we see, but these are the smaller implications. The bigger implications are sustainability, where we need to understand from where from the point of the value chain where we are emitting carbon and how to take care of that. So like we can optimize the plant, that reduces, but in the product scenario, product development, how to reduce that. So all these plays, they need chemical engineering knowledge, and they need to mix with the knowledge of different areas like sustainability means environmental science and other stuff. It's an interdisciplinary area, and you may well go for this particular area, which is a very buzzing area nowadays. Everybody is working and everybody is damn serious. They are investing in it. They say for recycled plastic. So recycled plastic is a big thing. So, but how to ensure the quality? How do you ensure the safety once it is recycled back? Who is measuring that? All these things you need knowledge with chemical engineering merged with or reinforced with the sustainability, the green angles, the environment angle, and there is lots of other things are there associated. That is one of the area. Second is new mobility. If we look at this flying car, this space technology or EV is a big area. Now, electric vehicle is also linked with say lowering carbon emission, but the batteries what we design, they have involved lots of electrochemistry applications, and designing a battery in electrochemistry related application and then scaling it up. So that requires a knowledge of chemical engineering along with the knowledge of automotive, along with the knowledge of uh, electrochemistry and the knowledge of composite. When you make a EV vehicle, the body of the car should be made of a material which is lightweight. So those kind of things are also going on in lots of research is going on, and there's an integrated research. So automotive plus the battery plus the whole value chain is getting created, and India is supposed to be the market supposed to expand very fast based on the current policy changes. So this is one of the areas. Then you say flying car. So flying car is lots of videos we look at, or lots of startups are trying that. But flying cars also need specialized materials, specialized control systems, specialized application of the material. How you design that? What kind of aerodynamic drag you have? What kind of fluid mechanics is applied? So computational fluid dynamics is one of the areas which is very well applied in this kind of areas. Then comes space technology. More and more we are hearing about different space technologies, space tourism, and also startups where they want to take out the inactive satellites. All these things are going on. So for space technology, you when you want to send this satellites to a different planet, or you want to build a house in a different planet by its 3D printing materials and other stuff, you need the material, you need the composite, you need the kind of what I can say, the fuel which will help us to go to a longer distance. All these things we need, and for this the chemical engineering is very much relevant to work in these areas, which is basically interdisciplinary. And these are the areas which is very emerging areas. You have scope to go in. It's not saturated. New dimensions are coming in, new technologies coming in, new applications coming in. So this is a new mobility. Then there is obviously bio. So bio and like pharma is one of the key areas where India is very well placed. I mean, from the pandemic last year, so I just started digging in how India is placed in pharma and what kind of things are required. If suppose I want to go to pharma background, so pharma has part of the bio, part of the chemical engineering. You have that applications in there. Scaling up basically a system, and like say COVID vaccine thing, lots of research went on, and in starting from the industry, streamlining the manufacturing to scaling up the research from the lab to the factory. Everything basically is chemical engineering needs to be there. The knowledge needs to be there, but it merges with the bio. Second is the drug delivery. This lots of application is going on in drug delivery nowadays, or detecting the mechanism, the how the body works, and taking preventive measures. So all of you may have heard of the preventive maintenance of plants. If you just go to your mobile, go to your Amazon, search an app called Dozy, DOZEE, you will find it out. There's an app is there. It's a data science based startup by IIT Bombay Alumni. And what they do is that they study the human behavior, the heart rate or the different parameters, and they create the alarm kind of thing that you can have this kind of symptom. This means you can have a heart attack, you can have different ailments, and that's how they create a preventive maintenance kind of alarm where you get diagnosed and you basically save a person. So this kind of things are bioinformatics related things are pretty interesting, and bio is a interesting area, which is biomimicry, nature inspired things many people are doing, like say lotus leaf, hydrophobic surfaces. All these research is going on, that how to take care of that, how to mimic the nature, how to put it in our real life applications. So there we have lots of bio and chemical related applications are there, where chemical engineering on their higher studies, if they don't want to pursue the main core chemical, they can go in these areas. And many of my colleagues, many of my seniors, they are very very successful in this kind of bio-related areas, where they're working extensively, as well as this last two areas what I talked about. Coming to the next one is nanoparticles. There are lots of things are going on in nanoparticles, nanocomposites, even in drug delivery, in even for example, in traditional chemical engineering, say for heat exchanger, they have started trying with the nanofluids, which they have seen that they are having better properties for heat transfer, which can make the overall size of the equipment shorter. So it reduces the overall cost associated with installing it, designing it, having it, placing it, everything. All this plot plan, everything is small. So that way also this kind of researches are going on. If you check some journals, lots of research is going on there, and nano is applied in everywhere, from medical to code engineering to everywhere. Then comes the defense technologies. So as we see here that lots of defense techs related buzz is going on in the industry. Lots of new companies are coming in, lots of JVs are being formed. So the whole value chain is getting formed inside India, and India's value chain is getting connected with the world. And in this kind of defense, there are dual use technologies like fuel cells. So like hydrogen fuel cells, you can use in submarines, or some cars. But again, you can use it in like in place of the electric vehicle, you can have hydrogen fuel cell driven vehicles. That also has its own application. But those are the dual defense techs. For having, say, for armored vehicles, say for the air traps or submarines, anti-aircraft. So they need specialized material. They need specialized material, specialized sensors, and that needs good amount of research to come out with our own thing, our own technology, and that needs good amount of effort in going in deep into there and developing, like DRDO is doing. Even for space, we are talking about ISRO, or NASA, and all these organizations, they are doing a wonderful work. And there we have role for chemical engineers and the kind of interdisciplinary role they play. Even in the electronics, we have chemical vapor deposition is very well known application of chemical engineering in electronics. And in the Fogler's book, you'll find the whole description of the chemical vapor deposition. But the thing is that they're applied, and they are basically they also recruit sometimes the chemical engineers for this kind of things, and that the chemical engineer needs to know the part of the electronics, how it will help them, how what are the different aspects of designing that in that way. All these aspects are there. So in a real world problem, we are like passing out as a chemical, somebody's coming as electrical. But in a real world problem solving, you have scientists, you have techies, you have entrepreneurs, you have policymakers, everyone coming in, and that gives us a sustainable solution. So there are lots of scopes are available beyond these also. These are a couple of areas what I've figured it out here. But rather than that, you have data science. You have data science means data analytics coupled with chemical, data analytics coupled with bio. All these aspects are there, where a chemical engineering from going from his core chemical B.Tech, after that he or she can go to a different level during a higher studies. Next slide. So yeah, so here, as I was mentioning in the previous slide, uh, what I was talking about. So what are the scopes in higher studies? So one is obviously the interdisciplinary research in nano, bio, or even in different areas. What I mentioned in fuel cells or everything. Apart from that, if somebody wants to do a research in core chemical, what are the scopes? So there scopes are there in core chemical, but as you can see here, the things are saturated a little bit uh, from the what has been the interdisciplinary research. There are spaces to explore, but here we have a interesting topic called process intensification, where basically you merge the unit operations and make a intelligent unit operation process, a hybrid process, which can have better efficiency, as well as the scope of the cost actually comes down because you merge the unit operations. The overall installation cost comes down, the fabrication cost comes down, the whole value chain is created there. So there is a good amount of research is going on in process intensification, as well as the cost computation, the cost estimation. There are if you not believe me, that there are lots of good amount of high paying jobs are available after higher studies for cost estimation and cost estimation analysis algorithm. There is lots of softwares are coming in, specialized softwares. We all might have heard of Aspen or HiSeas or HDRI or KG Tower. But what goes behind all these softwares? You have a chemical knowledge, chemical engineering knowledge, and then you have the software coming in with its own user experience or own specialization, own utility, that it can make your life easier. For example, like I recently did a beta testing of Aspen's one of the versions, which is embedded data science or AI/ML, artificial intelligence, machine learning into it. So you can have the what you can say, neural networks. You can do the kinetics estimation using a neural networks. You can have a real-time process optimization if you bring a model. Those kinds of uh, capabilities are there, and that needs specialized skill sets, that needs specialized understanding. So during higher studies you will get all these kind of areas to explore. So while you are doing higher studies, the project is a very important part. So in this MTech project, we should have, when we're doing for higher study, we can look for this kind of opportunity if you're looking for a core studies, and that adds value. So there is one of the softwares which is only used for kinetics reaction, kinetics estimation and reactor modeling, and that has all kinds of reactor modeling facilities are there. But that needs good amount of understanding how the reaction goes, what are different type of reactions, and that actually makes you a SME or a subject matter expert if you work in that area, maybe in your MTech and then job, then PhD if you look into. So there are those kind of things are also there. Then there is industry sponsored research. So if I give an example, say for in Scandinavian countries, if you look at Denmark Technological University like DTU or NTNU, here you have PhDs of 3 years, 3 to 3.5 years, and they are pretty like strict about the criteria, what they want, what the kind of people they want to work. So they'll give you the industry sponsored projects. It's fully sponsored by industry. They have a live plan running, and you have under DTU problem solving mechanism is there where you apply. There you do a PhD for 3 or 3.5 years, and you solve a real time problem there. So those are the industry sponsored research. And what I understand now in India also, there are lots of this kind of research topics, research subjects are coming in, which is increasing actually. I mean, I will not say it was not there earlier, but the quantum is increasing, which is very good sign. But those areas are in Europe. Generally, the PhDs in Europe are like this. So 3 and 3.5 years, you get a concentrated focus project. You need to finish it. You need to show a progress, and there are lots of parameters to measure your success. So those are the areas you can look into, even in same in NTNU also. As I mentioned of the interdisciplinary research, what you can do in my previous slide, there are lots of scope in different areas. Different even if we say look at our IIT Bombay uh, research areas, there are wide array of areas of research from say molecular simulation, molecular dynamics, where you measure a property of a particular component by statistical thermodynamics, or that is one of the areas of research. Because when I say about all these softwares I use for my plant support or kinetics estimation, I need a proper thermodynamics, right? And who will give me that? That needs someone to read there, someone to have expertise to tell me that, yeah, I can, I need to, this is the correct property, you use that. Those are the kind of researches going on. Yeah. Then after the higher studies, so once you do an MTech or a PhD, what are the scopes? Those are different scopes are there. One is the industrial research. Those the industrial research R&Ds. What, like I am there in SABIC say, and we are doing some kind of research in different topics. I'll come in detail later what kind of things I do in the next slide. So the industrial research is basically utilizing your skill sets what you acquired during your higher studies, and applying them and learning new skill in this process. So you, if you worked in say process synthesis or process optimization or intensification, those know-hows, how you use that in those R&Ds, corporate R&Ds. Then we have information research. So as I mentioned, like about my friend is IHS or Nexant. So IHS or Nexant, what they do market analysis of data as well as technology. So data, when IHS says a particular polymer cell will reduce because of the, as we are watching most more of Amazon or say Netflix or Hotstar, it actually looks to me surprising if we suddenly hear this kind of statement. But suppose if I tell you that when IHS is saying that they are studying the DVD or the CD of Mozart or whatever we buy, the material what is used here, that is not being utilized because the rate of piracy has come down, the rate of usage of CD DVDs has come down because of wide internet connectivity. That actually makes us connected with the kind of things what is bringing in. So as the CD or DVD usage is going down, the material usage is going down. So the market of this particular material is going to take a hit in this particular application. But it has to evolve. If it has to bring in more revenue for a particular company, it has to go in a certain direction, other emerging applications. This is the kind of work IHS brings out, the kind of information. Next time, similarly, compares the emerging technologies and gives me a well-rounded approach that which kind of technologies are available, with which I can benchmark my own technology. I can do cost estimation based on this. So this also requires a specialized skill set of cost estimation, understanding market, along with the skill of chemical engineering. Then comes the intellectual property. So patenting. So if you have an idea, you can patent it. And this patenting requires lots of understanding on the chemical engineering. There is like chemical, like IP councils are there. If we file an idea, they have to fight there, they have to take information from us, they have to fight there with their own understanding and win a case. Basically it's a court case, basically you have to win, and that's require lots of understanding of how we frame an intellectual property, what is our opposition, our competitors are doing, what we are doing, what is the opportunity space, understanding that. That also is a very interesting topic, gaining traction in India, and lots of firms are working, and it also they are applying lots of data science and automation applications also they are doing it. And then there are research labs in, if you go to abroad, then lots of research labs are there where you can have lots of scope in uh, you know contributing using your niche skill sets. Say you are very good at say like bio-related one application or composite making, or you worked in carbon nanotubes, suppose for example, or you work say in the COVID related medicine. So all these kind of research labs are there. You can find it out, all these areas, these are the scopes available. Next comes the faculty part. So in IITs or like the foreign universities, there are faculty positions, lots of better research capabilities are also present. So you can be a faculty, run your own research, have a industry collaboration projects, That can help you in long run establishing yourself as a subject matter expert in a particular industry, in a particular topic. That is one of the areas. Next slide. Yeah, I'll briefly talk about my transformation. But Tanika, how much time do you have now? Like, am I overshooting or?
Sir, it's almost 6 o'clock. It's 13 minutes to 6.
Okay.
So it's
Yeah.
fine. Another 5, 7 minutes you can go on.
Okay. Okay. Cool. So when I joined the SABIC, I worked in nanoparticle modeling, as you understand, in MATLAB, population balance algorithm, and then I got into the world of Aspen HYSYS and all these things, process actually mimicking a plant performance in a simulation, or rating exchanges, rating columns, distillation columns, and seeing real time. And then I learned new skill sets, as well as during the process I applied the already existing skill sets what I had, like say multivariate statistics. I think at our time Mani Bhushan used to teach us multivariate statistics or optimization. All these things came into play because suppose I was doing a planned optimization, and there I was getting some unwanted reactants, and there is no kinetics available in the world. In the world there's no journal available where it actually predicts correctly, reliably, the performance of that particular chemical formation. So I used my multivariate statistics skill to have a hybrid model where I have a first principle model coupled with my multiple linear regression skills, and I apply that and solve this issue, predict the kinetics. Then I worked in energy studies where you optimize the columns, you reduce the utilization of steams, and that actually adds to the sustainability, uses the energy intensity of the plant. Then I worked in conceptual process development, where actually what you learned in your B.Tech as well as your masters comes into play, choosing from the thermodynamics to the transport to the the mass transfer, how it takes place, what is the overall cost, what is the overall value chain, and that's how I learned in step by step in different scenarios how it goes, and this actually sharpened my problem solving approach. So now if a new problem is given to me, I can at least know that how to do that, how to take care of the problem. And that's the beauty of doing a higher study, having some analytical skills. And that's what, in my opinion, it is that it helped me quite a lot to see through these problems, and some of them are implemented in the industry also. uh, Next one, and last but not the least, there's a few word of advice is, think thoroughly about your career interest and all the circumstances you are in. So our own circumstances are different. We have some internal, we have some external situations. Think about it carefully. About when we are thinking about the career opportunities, there will be ups and downs in life, there will be failures in life, but don't be afraid to fail. I mean, have failure, but we learn many things from the failure. Because even I'm talking to you about all these things, but I also had lots of failure while I entered the job in 2014, and from there to now on. But now I learned how to deal with that, how to take care. And life gives us opportunities. We can decide on when to take, how to take. That's up to us. But don't get stressed out that what you are doing and others are doing, what you are doing, don't compare. Everybody has a special capability, special talent, and explore that what special you have, what you are passionate about, and then explore that part. And obviously maintain a close group of friends, like your friends, your boyfriends, your girlfriends, your parents, everyone. You can have a group of friends, you can share your problems, talk to them, have interaction. That actually gives us lots of clarity, and also the exchange of thoughts actually opens up new areas, new understandings for us. And most importantly, inside the college we are there this 4 years or 2 years, or have fun. It's very important to have fun in every circumstances. Even if you go for a higher study and all, like, you should have fun because it helps you soak in to the environment. So when I came first from Calcutta to IITB, the first time I came out, so going with the B.Techs or the other people help me soak in, sink in into the IITB hostel culture, and then actually it helped me a lot uh, to in my next year of studies and next year of working. So this is it from my side. Thank you so much.
Anyone who'd like to ask questions, you can. I'll unmute all of you. Like I'll allow all of you to unmute. So please ask your questions. Yes, I hope you can unmute yourselves now. So do go ahead and ask, sir. If you want, you can also type it in the chat box, and I can ask the question for you. Anyone? Any questions? So would you like to share any credentials where people could get in touch with you in case they had any questions in later?
Yeah, my LinkedIn profile is there. Like you can maybe share LinkedIn profile, or that there you can connect, and you have my email IDs or anything. Like, I'm available in LinkedIn. I think if you have the link, maybe you can share. So if there is no question, maybe I can one short story I can share if we have 1 or 2 minutes. That
Sure, sir.
uh, there are situations in life that you can feel like uh, nothing is going right, or I don't have the career options what I have looks bleak, or the jobs I am looking forward does not. But there's a similar situation happened in Vietnam in 1990, where one person called Jerry Steiner, I think, in 1990 came, and his motto was to save the children. Malnutrition was a very big problem, and he has only 6 months. So what he did is that he understood that in 6 months he cannot solve the problems because of sanitization, because of all these things. It had problems. Uh, so what he did is that he made a bright spot. He found out that out of those malnutrition children, which are the healthy one, and based on their regime from their mothers, he understood what they are feeding. That thing they replicated. So what I did is that he found out a bright spot out of all these negative things, and that he replicated inside other children's other mothers. He told us follow this kind of procedure. That helped. That in 6 months 65% people, um, children came out of those malnutrition thing. So in life, if you have any problem, try to find a bright spot and try to clone it. That's the only thing I'll want to give. I hope there's some takeaways which can benefit all of you.
Thank you so much, sir. That was really insightful. So if
Thank you.
we don't have any questions, I think we can probably call it a day. Thank you, sir, so much for your time. It was a really informative talk. And to all the participants, thank you for joining in. I hope we can have more such sessions in the future as well.
Thank
Thank you
you.
so
Thank
much.
you so much.